Hello, everyone, and welcome to this episode of Crowded Beaker Solves. Today, we're continuing our series on drawing Lewis structures, and we're going to do a couple of Lewis structures that are sometimes problematic for people who draw them. I've seen one of these at least recently on an AP chemistry exam, so I show it to my AP chemistry students as well. If you're unfamiliar with drawing Lewis structures and the steps for doing so, you can feel free to go back to one of my earlier videos, but we will be modeling the steps here. So the first step is to add up the total number of valence electrons that you have in your structure. Using your periodic table, you'll find that sulfur is in column 6, so 6 valence electrons. Carbon is in column 4, nitrogen is in column 5. And just a reminder that if you do see a charge, you have to add or subtract to the total for your number of electrons. If it's -1, we're going to add 1 to the total. So I have 16 total electrons here in this structure that I have to work with. Okay, so what we're going to do then is to start by drawing a skeleton structure, and we're going to use the order that they are in, so S, C, and for these types of ions, it's often written in the chemical formula as to which order they actually do come in. So we're going to start by giving them both a single bond. That's 2 electrons, 4 electrons. So I've got 12 more to go. And so let's go ahead. The next step is to add them to the outer electrons, or outer atoms, and give them all an octet of electrons. So that means starting on the outside, 2, 4, 6, 8, 2, 4, 6, 8. And I get to this point where I have used up all my electrons. I don't have any more to go, but then I have to scan it over and make sure everything looks right. Right now, it does not look right to me because the carbon does not have an octet of electrons. I've just run out, and so when this happens, you've run out of electrons, the central atom needs more, you're going to shift some electrons in and turn them into double or triple bonds. Make these electrons do double duty. Now I can take those off and shift them in and give them a double bond between the sulfur and carbon, and I still have 2 more to go. So I have a choice here of where I want to put them. And in fact, there are 3 different ways I could probably draw this thing. I'm just going to start with the most symmetrical one, bringing a pair in from this side. So the sulfur and the nitrogen now both have 2, 4, 6, 8, 2 lone pairs and 2 bonds in that double bond. And that's kind of a nice symmetrical type bond arrangement. And that's one of them. Now, you might be sitting there at home going, well, yes, I see that, but wouldn't it be possible to do a triple bond and a single bond? And you're right. Yes, it would be possible. So I'm just going to go ahead and redraw them. I'm going to do this part quickly. It's very possible that I could have just done 2 on the nitrogen side, leaving the sulfur with a single bond and its 3 pairs of electrons. And you could also go in the other direction and put a triple bond here and a single bond here. Now, all 3 of these are valid Lewis structures, just based on the rules and following them through. All of them follow the octet rule. Everything's satisfied. We've got the correct number of electrons, and we've even got brackets in the charge. These are all essentially resonance structures of each other. We covered resonance also in one of our previous videos, but resonance occurs when you can have more than one possible arrangement of those double or triple bonds within the molecule. Now, you might be wondering, that's great. You've got 3 Lewis structures, and they're all nice, but which one is most likely? Which one is the most stable form of this ion? And I will be making a separate video talking about formal charge and how we can use formal charge to answer that question. But in the meantime, it is your turn to try to draw a Lewis structure. It's related to this one, but it's without the sulfur. So we have drawing the Lewis structure for cyanide ion, which is Cn with a 1- charge. So feel free to take a moment, pause the video, draw the Lewis structure, and then in a moment I'll show you the solution for that one. Okay, so if you were able to draw the Lewis structure and realize that there's only one way to correctly get 10 electrons to satisfy 2 atoms with an octet, and that is to have a triple bond and a pair of electrons on both, then congratulations, you're becoming an excellent Lewis structure drawer. And of course, once again, do the brackets and the charge around it. So We have the two Lewis structures for thiocyanate and cyanate, two related structures. Um, if you have any questions or if you have suggestions of molecules you'd like me to draw, you can send them to me. In the meantime, happy drawing and have a great day.